What's up everybody, welcome back to the channel. In the last video we showed you how to replace the battery pack in a 2019 MG ZS EV for a battery that we bought from a scrapyard for £2,500. In this video we're going to open up the old pack and show you the modules and the cells inside, and then talk about maybe what we're going to do with that pack next. So let's get into it. Time to strip the battery down.
So across all these cables coming in and going to all the cells, so you'll have various voltages up to 400 volts, depending which wires you decide to grab hold of. One needs to be very cautious when you're pulling these wires out, because these will all be live. A lifetime of dealing with live plugs, but again, they're all pretty well insulated, and as long as you're not stupid and try sticking your fingers in things.
Yeah.
And I would assume that that's high voltage as well, as it's got nice orange on it, but whether they keep to the colour codes in here, who knows?
Yeah, they will.
That's it, so we can now look.
A couple of T40 torques to hold the actual BMS unit in place. And out comes the BMS.
Have a look in there, that looks expensive, doesn't it?
I'm sure it is.
Yeah, that looks expensive. Okay, so our next job will be these around the outer edge.
What do we reckon? About 150 of those? 6mm hex heads?
I'll count them, shall I? Go on.
This time we won't forget about these ones hiding in the middle.
Big ones in the middle,
Yeah.
That's all plastic as well.
How many was that then?
I didn't count, I'll give up.
Oh, after all that.
Yeah, I've run out of fingers.
Right, what size was that? 32?
32.
Yeah.
Not really tight.
Nothing on this has been overly tight, has it?
It's slipped up. Well, it's, at the end of the day, it's only holding a plastic cover, isn't it?
Oh, well, yeah, it's sandwiching that and the pack to the car, but
Yeah, but, I mean, this is like a hat into the tube underneath, so it's only just nipping the plastic cover. You know, it's a top hat into the tube underneath. I think we'll disregard that bit.
yes.
Yeah, I think it'll be a little bit higher than that. So, theoretically,
Just breaking the weather seal.
and you can smell it.
And off comes the top cover.
No, it is steel. Yeah, that is steel.
It
I
is.
thought it was plastic.
Yeah, it's
But
very much
it is-
steel.
It is steel.
Yep.
Okay.
Right, so now we've got the top cover off, and then we've got this insulating material that we then need to remove to expose the modules. That's literally just stuck down, isn't it?
It is literally just like a slight sticky. It's still sticky now, you know,
Yeah.
so you can put it back again. So again, that's giving access to the other side of the battery modules.
That's under that frame, isn't it? So you're going to need to take that screw there, Bill,
Yeah, there's one there.
and that one and that, those four,
Yeah,
to remove the
need to-
BMS frame.
Need to just lift this up from the cover, you see, as well. There's another one hiding there. So, let's see if we can take that out.
So we're just going to release the BMS harnessing from the frame. Another one there, mate.
As well.
That will allow all of that to then slide through the captive end of that BMS frame there.
Now lift that away, just down the middle. Oh,
Now we've got a ground.
Now they've put a ground on it for us.
Yeah.
But they've made it difficult by putting a connection underneath, haven't they? Look.
And that is our BMS frame released. There we are.
So each one of those is a module with 6 cells in it. In series, giving out a 21 volt pack.
Right, and there we go. There are all our battery modules. And we can see it still, so obviously it's left the tape residue behind from the covers. You can see now the exposed cooling channel ports. So these are the cooling pipes running the coolant down to the lower coolant base. That's the inside of the cooling channels there. And then all of our interlink LV comms and BMS cables and all the bus bars. Super simple, really. It's quite a basic but effective design.
Very simple and very serviceable.
Right then, so we're now on just stick a meter on both ends of the battery. We can tell that by the bus bars that are going into the main connection. So that bus bar runs directly into that pack. And the other one you can just see sort of running along there. And then that goes all the way to the end. So we have our meter on the end of that. And that's showing us
434 volts.
434 volts.
Okay, so we want to find half of it, don't we, really?
What are you doing, Bill?
We're measuring all the cell block voltages for each block, so that's 24.1. So 4.1, then I know what they all are. This is what been sat here a week since it's been charged, so they should have all settled.
Well, they seem pretty consistent, don't they?
And hopefully, if we've got one that's got a duff cell, 24.12.
Right, so you've been rolling the tape off, the cover tape, by the looks of it.
Yeah, what I find is the easiest way is I just sort of did a bit of that. Don't plan to use this again for what I'm going to use the batteries. And I just find it's just easier just to roll it off and keeps it all together.
Okay, so now that's done and we've characterised all of the batteries. So we know exactly what they're all sat at currently, which will come in useful later. We're going to now take all of the LV comms cables out.
It's all the balancing wires, so they just
drop out there slightly, just a little detent that just pushes down and they pop out. Obviously, again, be very careful where you're putting hands and screwdrivers here. Just be mindful that you're working alongside high voltage.
Yeah, the thing to bear in mind, in my trade, we call this low voltage.
Well, yes, okay. In an industrial sense, yes, these are. But in an automotive sense, these are very much high voltage.
At the end of the day,
I feel it still kill you.
it only takes 10 milliamps to kill you. So treat it all with respect. Yeah, I mean, they're pretty well covered up for the rating, okay? I mean, I would have to really try hard to push my finger in to get onto those slide connections.
You would?
But that would go in quite easy, hence the insulated screwdriver.
Yeah, so all of the bus bars and the bus bar connections are all covered by this little touch-proof cap here, which looks like it just slides upwards. So we'll get a screwdriver in just in there, in between, and we'll just pop that cap up, and that'll expose the bolt. You can just see it under there, which is the bolt length for the bus bar to break the HV connection. The bus bars themselves are also insulated for touch protection in the centres of them too, as you can see.
Yeah, so at this sort of high voltage, you would probably feel a little bit of a tingle to you to earth if you grab it. Literally, what you're seeing is that you'll be charging like a capacitor, but there'll be enough current flow there just to make you feel the tingle.
Yeah.
So it probably would be advisable to have some gloves on when you're dropping those bolts out.
So this next bit comes back to what we were saying before about understanding exactly what the electrons are trying to do and what you need to do to protect yourself. And I can't wait for the comments. Why that module, I hear you say? Well, simply it's the halfway point of the pack. So by taking that one first, we're halving the voltage of the pack that we're working on. And we'll keep doing the same strategy throughout to keep it as safe as possible. You'll see we're also wearing some rubber tip gloves as well, and really that's just to stop any chance of feeling a small capacitive drain from the modules to the actual aluminium casing, just to be on the extra safe side.
So just prise it forward, and that leaves us access to that bus bar.
Right then, so we're going to go and take the first bus bar off. You can see we've put some tape around the end of the driver bit, just to insulate, but more importantly just to make sure that it doesn't fall off the gun and we don't end up dropping it somewhere where we don't want it. Right, then we're going to remove the clip.
I think the easiest way will be to cut it actually. And the others did pull out. Will that one pull out? Oh, I don't know, maybe. So we bring that away.
And that is our bus bar out.
So that's the first one. So we'll take the next one and then we'll have dropped the voltages of the strings to quite a low voltage. So now what we'll see.
We go back to our main bus bar points.
This point here and there. Right.
We've got a grand total of 1 volt decaying.
Yeah, now again, let's let the meter discharge. Let's come back, and what we're going to do is we're going to make that connection again, and what you'll see, that's the capacitive charge, as it's just equalising, because it is open circuit. So there's a very slight voltage there, but nothing. And again, if we now go to the case, you'll see how the voltage to the case that we had before is
now gone.
Very, very well. Momentarily 100 volts, which is the capacitive charge.
Yeah.
But that's going to be a small tingle that you'll feel, but it's gone within seconds. The thing is, I've got a lifetime of experience of working with electricity and batteries. You know, so this is sort of what I deal with each day with UPS systems and that. So you get quite familiar in some respects. So you know, if you're not sure of what it is you're doing, you need to ask somebody's help or do a lot of research into what you're doing until you understand what you're doing. But I'll say, you know, this, you know, I don't need to go over the top, just some simple precautions, you know. Again, do the ones you're working on. There's no, why take all this protection away? Just do the ones that you're working on, and then if anything did fall onto that or anything else,
the protection's still there.
You've got some protection there, you know. It's
I have to say, it's pretty well thought out, this battery pack, isn't it?
I've got to say, I'm actually very impressed because, I mean, all I can compare is some of these others that I've seen stripped down that people are doing on YouTube. and everything is spot welded, and they're having to cut through links that are all live and do all of this, and you're thinking, seriously? This battery was designed, you know, if I wanted to change that cell, all I need to do is remove the links around it, disconnect those cables, 4 bolts, lift that out and put the new one in, put it back, put the covers on.
Yep.
Service, job done, you know, your batteries will play it, sir. Bearing in mind, our friends at MG are telling me that to replace this battery, they'd want about £20,000 just for buying the battery.
Yep.
Well, I'm sure that for £20,000 I could go onto the old websites and buy these modules, because this isn't actually one battery. When we drop the cover off this later, this is actually 6 individual cells, and those I expect we'll see they've probably been spot welded.
Yeah.
So as a module, it's easy. If you get down to an individual cell, it'll be a bit more involved.
But what's interesting is that when you look at this kind of topology compared to something like a cylindrical layout of a Tesla, you know, yes, they're more energy dense because they're much tighter packed, but then you couldn't work in this way with those kind of battery packs.
No.
They're not serviceable in the way that this is, and yes, you lose a little bit of packaging space, a bit of energy density as a result. But how easy is this to work on?
Yeah.
So now we've removed all of the bus bar links between all of the modules. So essentially we're down now to multiple 21 volt modules. So now it's time to start thinking about taking off these mounting screws for each of the modules, and we can actually remove those from the carrier.
Again, these are going to be long bolts.
Well, these are all screwing down to the bottom of the cooling pack, yeah, into the base.
See, they're all long bolts, and it's these sort of things you don't want to drop,
because they will bridge across contacts.
especially if you're taking out just one cell and you're leaving all the others in place.
So while we're doing that, Bill, sit rep on the MG ZS, having changed the pack out.
Having changed the pack out, it's got its wings all over again. I can now get down to less than 10 miles range, and I can still do 70 miles an hour down the dual carriageway, which for the last year and year and a half has maybe been a bit of a struggle. But then again,
With this pack.
this pack is 115,000 miles.
So it's done some work.
8 or 9 years use of the average user in less than 4 years. Whether you can just get a little pry bar under that corner just to break it, because that is actually stuck down quite well.
Yeah, we can just see under that edge there. So that whole block will lift with the module. So this is the fun bit. All of the bolts are released now, as you can see. And now we've actually physically got to get something underneath, because these aren't overly light modules, and they're stuck down onto the cooling pad, which is this here. So we just need to get something to help us release those and make some space. Now obviously, again, exercise some common sense and caution, sticking things in there, but as you can see, we're just loosening up.
The live bit's there and there, so you know.
And we've put the caps back on to cover the battery tabs, so we can be pretty confident. We're just starting to loosen up on the thermal pad. Hopefully we can pop all these out. There she goes. And there we have it. There is our one lithium module.
One lithium module.
And then we can see, look, down there is the thermal pad that it sits on, which transfers all that cooling from the plate. That's quite a hefty sized thermal pad in it as well, actually. There's a fair amount of transfer that will go through that. Okay, and now we can repeat the process. Anyone would think these things were heavy.
It's not that these are heavy, it's just I'm weak.
Well, they're sat on little spigots as well. There we go, look.
Oh yeah, they are.
Sat on little locating spigots.
They are located to stop any movement. That looks good.
Yeah. There we go. That is all of the modules out of the pack. And that is what remains. And it's not a lot, really.
And it's a lot lighter than it was.
So we're just having a little look at the case, and actually the solution they came up with is quite clever. So it's got 3 individual cooling plates. As you can see, the actual cooling lines are split and teed off here. But the way they've done it with the casting is that they've cast a recess into the base of each of these 3 segments, and they'll have a cast sort of cooling path that goes like that, loops up and down. But then what they've actually done is they've put a plate in on top of it and welded that down. You can see the weld here, where they've then ground that flat to create the flat base for the batteries to sit on. So that is actually an individual plate which has gone in separately with the temp sensor and the cooling channel parts, and then welded in place. So it's quite neat, really. So you've got a black tab, you've got a black case and a grey case.
Yeah, one's M for master, the grey's S for slave.
Okay.
And you'll see on the master you've got 2 connection points, and on the slave there's only 1 connection point. So on the master you're confronted with 1, 2, 3, 4, 5, 6 cells, and this all forms part of the BMS system. So basically, if we take that as the master and then we look at what's actually in a slave, you can see there's a lot different. And then when it's joined together, it'll be in that configuration with a link cable, and that is 1 string of 12. So it's a 12S string with a BMS on it, or the BMS board, and that all feeds back to the main module.
Okay, and then we've got these tabs here which have been welded on.
Yeah, these are all aluminium links.
There we go, and that's what's inside the pack at cell level. And that's it for this video. Thank you so much for watching. We hope you enjoyed finding out a little bit more about what goes into these EV packs. And if you did, don't forget to like and subscribe and hit that bell button. And you can catch us with the next video when we'll show what we're going to be doing with the modules that we've just pulled out. And whatever you drive, EV or petrol or diesel, it's all just interesting technology, right?